going on right now in the marketplace and what you can probably anticipate in the future. And of course, let me get on that. There we go. So the whole reason why we're changing is not because we've encountered a better technology from what we were using. It's actually the only reason is for climate change and environmental reasons. And it's the same reason why, if some of you recall, the CFC phased out in the 1980s, Montreal Protocol. It was the same thing. For years, the industry used chlorinated refrigerants, and by putting chlorine in the refrigerant, and what I mean by that is CFC was R12, HCFC was R22, chlorine again. By putting chlorine in the molecule, it gave it really good attributes. Chlorine is a natural solvent, so it dissolved in most oils. It was it added a non-flammable part to the molecule itself. So we had these great refrigerants, but they were chlorinated, and chlorine, when it got up to the upper atmosphere, reacted with ozone and depleted the ozone layer. I think for every one chlorine, 2 ozones were destroyed. So we had to move away from them. And the most logical molecules to go to were HFCs, hydrofluorocarbons. And that's what we were using since the early 90s. And we knew that in the early 90s, because this is when I worked in our research lab, that this climate change thing was just starting to come about, and that these gases did have an atmospheric lifetime associated with them. But at the time in the 90s, it wasn't as important as getting rid of the ozone depleting substances. So we moved right to these gases, but some in the industry kind of knew that they had this long atmospheric lifetime, which added to climate change. And how that adds to it, greenhouse gas, you'll hear that a lot. So what is that? It's a measurement compared to CO2. So when we measure greenhouse gases, it's always in relationship to CO2. So if we think CO2 is 1, say R410 is 2100. So it has, whatever has a greenhouse gas number associated with it, global warming potential, a GWP value, it's always relative to CO2, because that's the dominant gas in the upper atmosphere trapping heat. Because of the high GWP values associated with some refrigerants, we're getting rid of them. And we're moving to refrigerants with a lower GWP value. But it's not that easy, because there isn't that many solutions to go to, as I'll explain as we go through this presentation. So right now, basically any refrigerant with a GWP more than 700 is considered high. And that's most of the ones we're currently using. And forgive me the typo here. If you see R32 equals GWP, it should be 677. That's my bad. Sorry about that. So what's the challenge with all this? Well, the challenge is to get underneath that GWP of 700. Most of the refrigerants that we look at are going to have a mild flammable component to them, or what we call a lower flammability classification. So no secret that many refrigerants that we've been using in the past were A1 flammability. And what the A's mean is that's ASHRAE assigns these measurements of flammability to refrigerants: A1, A2, and A3. And that was, for many years, it was just those 3. But then when we came out with these refrigerants of lower flammability, ASHRAE went back and said, well, these gases don't exactly fit in the A2 category, and they don't fit in the category of A1, being non-flammable. So they created a new measurement called A2L. And that's where the refrigerants of the future are probably going to fit into that category. We do have some that are non-flammable, or A1, but as you'll see, they're mostly on the low pressure, low capacity end, which limits their range in applications. And then, of course, there's highly flammable refrigerants, which is A3, and that would be your whole family of hydrocarbons: isobutane, isopentane, propane, etc. Would it be A3? If you're curious, So how do they get to those three classifications? Well, there's three measurements of flammability, or main measurements of flammability ASHRAE uses. How fast something burns, or we call it the burn velocity. How much of it you need it to burn, meaning what's the lowest amount you can have in a given volume for it to show a sign of a flame. And then once it does burn, how much heat energy is created. And to give you an idea of what these A2Ls, of how not, or how less flammable they are, if we take propane, burns at 39 centimeters a second, R32, which is one of the main replacements for 410A, burns at 6.7. So it burns 6 times slower than propane. And 1234YF, which is one of the refrigerants to replace 134A, again, lower pressure, lower capacity, that's in most of our automobiles now, newer automobiles, that's 1.5. So why burn velocity is important is basically the slower something burns, the more things you can put it out. And the more things that fire triangle needs to survive can quickly unconnect, let's say. So burn velocity, very important. These products don't, they burn much slower than the hydrocarbons. Lowest flame limit. Now remember, this is done in a chamber, a test chamber. So in the chamber, put in 2.1% of propane, and then they have a high energy element in there, light it, and you'll see a very small flicker of flame. So basically a very small amount of propane is needed to get that very small flicker of flame. Whereas with 32, it's considerable higher. It's that's 7 times more you need to see that very small flicker of flame. And then YF is 6.1%. And then heat of combustion, we're looking at R290, and this is megajoules per kilogram, is 46, R32 is 9, and YF is 10. So you're figuring that when they do burn, they're about, they have 4 times less the amount of heat energy that's created. So why I put this up there is to say that, hey, there are clear differences between a mildly flammable, or technically a lower flammable refrigerant, and a highly flammable refrigerant. And that needs to be stressed as we move into the future, because a lot of things are, different folks at the wholesale counter, your technicians are all standing in line, different things are talked about and saying, hey, I hear we're going to flammable refrigerants, and, propane is going into an air conditioning system. No, it's not correct. But yes, we are going to lower flammable refrigerants. And in some cases, the hydrocarbons as well, as I'll show you some of their applications. Moving away from the high GWP refrigerants is going to be in a step-down method. And if you could see, this chart comes from the EPA's website, and it kind of mimics the Kigali Agreement. The Kigali Agreement was an amendment to the Montreal Protocol, and it was signed by, I think, about 180 countries agreed to the Kigali Agreement to move away from high GWP refrigerants, and it's done in steps. So you'll see the first step here was already last year. We reduced the overall amount of, well, it gets a little complicated. I can't say that the overall amount of refrigerants is 10% less. Let's just, for purposes of this presentation, let's say the overall amount of refrigerants is 10% less last year. And then in 2024, it steps down another 30%. But basically, of all the refrigerants that can be sold, it's going to be decreased. And why it gets a little complicated is because it's not necessarily per pounds, but it's a million metric ton equivalent to CO2. So basically what that means is that, let's just say 2024, the industry could sell, this much R410, but they could sell much more R32 because it has a less million metric ton equivalent to it, if that makes sense. And that's the way the government designs this phase down the usage of these high GWP refrigerants. Is basically the high GWP refrigerants are going to get phased away first. And then as we move further along the line here at 2034 is another step down, 2029 is another step down. The industry will have to continue to use lower and lower GWP refrigerants in order to have enough to feed the marketplace. So hopefully I didn't confuse it that much on that, because I could do a half-hour presentation just on these calculations here. But basically 410 is going to be going away. Let's say 2024, you'll start to see R32 and R54B equipment. And why there's two refrigerants is because manufacturers weren't mandated to go with a certain refrigerant. They made decisions based on their own business models, on their own analysis. And what we have is some manufacturers going with R32 and some manufacturers going with 454B, both lower GWP values than 410A, obviously. So we'll start to see this equipment mostly, let's say in 2024. You're starting to see, you can see window units and PTACs already used in 32 out there. But let's say 2024 is really going to be one of the deciding years where we'll see more of the equipment out there. And it looks like 410A equipment will, the existing inventory will be able to be sold through 2026. And when we look at refrigeration, there's some other blends out there that you'll see of lower GWP values specific to refrigeration. I'm not going to get into them in this presentation right now, but again, be aware that you'll be seeing those as well. And as we move forward, here's one of the big debates is some people think that we're going to have to change again in 2023 to even lower GWP blends than these two up here. 32 is 677, 454B is four, like, let's just say 450 something. It's very close to actual the number, the GWP value. Some folks believe that we need to be under 150 to meet these targets, which would mean that we would need to switch again. So stay tuned for that presentation sometime later in the decade. I just went over this in that last slide. Again, 410 equipment will be able to be sold to. You'll still be able to get 410 equipment probably through 2026. Refrigeration a little bit different. There are some lower GWP blends. Also hydrocarbons in low charge systems. You'll see those in refrigeration. That means your propane, isobutane, etc. Industrial process cooling systems as well. You could see CO2, you could see ammonia, which can meet those targets as well. But most air conditioning manufacturers, like I said, are either going to be going to R32 or 454B. This change is also changing or fragmenting our industry a little bit more than other changes that we did, say, with the Montreal Protocol, because we'll still have chemical refrigerants out there, 32, 454B, the new family of molecules called hydrofluoroolefins. 1234YF is the most popular, but we have 1233ZD, 1234Z, blends containing those gases with 32. They're going to be around for a very long time. But also hydrocarbons, propane. If you're familiar, propane's thermodynamics are very similar to R22. Obviously, it's highly flammable. It's an A3, so you can't be using it where you used R32. But it is approved for small charge refrigeration equipment and some commercial equipment. So 55 grams in the U.S. is for residential, 117 on commercial. In Europe, it's actually I believe 260. Grams on their commercial end, which allows a manufacturer of, say, reach-in boxes, coolers, etc., to design around those limits, whereas here in America right now it's still at 117 grams. This does mean that there's probably a high probability if you go out to buy a refrigerator that it might be running a domestic refrigerator that it might be running on propane. This doesn't mean that a manufacturer such as GE or Whirlpool or one of the many other ones has to make a refrigerant on propane or using a hydrocarbon. It just gives them the ability to do so. They could choose to use that refrigerant as opposed to, say, YF or maybe a blend. CO2, very interesting refrigerant. As you know, it's an atmospheric gas. It has very unique properties because its critical temperature is only 88 degrees. To give you to compare that to R410 at 189 degrees, you would think, wow, what can be done with this refrigerant if its critical temperature is 88, meaning it really can't do much heat exchanging after that. But CO2 has unique thermodynamics where it has a subcritical application and a transcritical, sub being below that temperature range and trans being above it. The problem that we initially saw with CO2 for many years was that you're up above 1,000 psi to condense, or you're at those pressures to start to condense, and that's a lot of energy to get there. But the technology in CO2 has come a very long way, and the efficiencies that have been gained in it are just surprising from when we originally were looking at this back in, say, the 80s. So that's going to fill a void. Some supermarket systems, especially in the northern climates, will be using CO2 more. And then ammonia. Industrial process cooling has always been there. Unfortunately, it has a toxic and a flammable rating to it, but you're not going to see it going away. If anything, we might even see some more systems, again, in an industrial process cooling using ammonia. All right, this gives us a little history. So for many years, we use these HFCs. And why I had this slide up here is I want to give you an idea. If back in the 80s and 90s, when we moved away from R22, we got some pushback from technicians because we weren't using single component refrigerants. And technicians like single component refrigerants like R22 because you really get used to the PT relationship. There are no two charts or two columns in your PT chart. If it's 70 degrees, the pressure is this. That's it. Beer can cold on the evaporator. Technicians got really used to using R22. Now, all of a sudden, that's going away, and we brought in these refrigerants that have words like glide and fractionation associated with it, and technicians were getting all, kind of bent out of shape because the manufacturers were taking a very, very conservative approach. Let's just say with 410A here, which is 50% R32 and 50% 125. And these are different refrigerant components. And back in the 80s or 90s, we looked at four main refrigerant components as viable solutions: 32, 125, 143A, and 134A. So those four refrigerants made up 98% of all the 400 series blends that are out there in some capacity, like 410A, 50% 32, 50% 125. And why it was aggravating to some is, well, when you mix two refrigerants together, you have two different boiling points. So therefore, you're going to have glide. In fact, glide is within the refrigeration system. When a refrigerant is running through the evaporator, it's boiling at different temperatures. We call that glide. And when it fractionates, meaning, if you open up that cylinder to the atmosphere and you vent gas, it's not going to come out equally. It's going to fractionate. Maybe there's a high, the probability of 32 would come out disproportionate to 125 because it's a higher pressure. So back in the 90s, we were very conservative about that because we didn't understand glide and fractionation that much. Now, many years later, there are some phenomena going on with glide and fractionation that we still can't answer. Fractionation is a concern, but it's not as bad as we originally thought. But at any rate, the glide on 410A is like 0.03 degrees, where the glide on 407C is 11 degrees. So that is a big difference. We can't categorize all these blends together. But to step back a little bit, the reason why we blended these gases together in the first place is because each one of these components has an issue. Two of them are mildly flammable, 143A and 134, R32. Therefore, we couldn't mix those two gases together because we would have had a flammable blend. The reason why R32 and 125 are mixed 50-50, believe it or not, is to make that can of 410A or cylinder of 410A A1 or non-flammable. That's the only real reason the 125 is mixed in with the 32, is to make that gas non-flammable. Now, because GWP is a big issue, right? 125 is a 3,500 GWP. Well, it makes 410A a high GWP blend. So now we're forced with basically going with just 32 only and having to train the marketplace on what mildly flammable means. 407C was a blend of these three gases, and then why that is because 32, 125 are higher pressure. By putting 53% 134A in there, we brought down the pressure to 407C to where it could be used in a 22 system. That's the only reason that blends like that. In fact, 407C was a candidate to replace 22. It was between these two, and a lot of stuff happened that I'm not going to get into, a lot of with patents and what have you. But one of the things that was concerning about 407C back in the day there was the glide and fractionation associated with this. 404A happens to be a blend of these two gases, which have very high GWP, both of them. And that's why that gas has really already started to kind of disappear from the marketplace. And the manufacturers came up with these two blends here, 448 and 449, as an interim replacement, bringing down the GWP from 3922 down to 1400. So that answered like that's an interim replacement to say, all right, we can get rid of this right now because we have non-flammable blends here that'll work. 427A was our blend to replace 20 or retrofit for 22 equipment, and it was a little bit of a mix of everything. And again, all your retrofits for 22, you'll see a large amount of 134A in there, and it's to bring down the pressure to work in that 22 system without tripping it on high head pressure. And then 134A, single component application, refrigeration, automobiles, lower pressure, lower capacity, GWP 1430. So these guys are going away, and these guys are coming about, along with YF, YF to replace 134A as an in-kind replacement for automobile applications. If I'm going too fast here, feel free to ask a question. I'm not going to be able to read them. If you do type them in, I'll have to do that at the end of the presentation. I show this slide to technicians because most of them are familiar on how 22 ran. So if I ran this in a air conditioning on a hot day, 45-degree evaporator, this is the pressures that 22 would run at. And the capacity and the COP is the coefficient of performance, a measurement of efficiency, mass flow rate, how much refrigerant you need to run through a system, very important. Discharge temps, GWP, etc. When I look at R32, you see that it runs 62% higher pressure. Well, obviously, you're not using that in a 22 system, but it's 60% greater capacity, which is significant. Efficiency, a little bit less. Efficiency and capacity aren't linear when we look at refrigerants. And I make the analogy to a marathon runner. You can have a 90-year-old guy running the marathon and a 21-year-old kid running the marathon. The 21-year-old kid is going to do it much quicker, but probably burn more calories, where the 95-year-old guy could do it much slower, so less capacity, but he does it more efficient because he burns less calories. So refrigerants are kind of the same way. You got this great big refrigerant over here, 32, with all this capacity, but not as efficient as R22. 22 was just a great refrigerant, really. Mass flow rate, you need 36% less of it, which is key. Very, very interesting when we look at 32. Discharge temps, 34% greater. If you look at all these other refrigerants, they have lower discharge temps than 22. 22, the only thing it really suffered from besides ozone depletion was it had a high discharge temp. So Copeland actually came out in refrigeration, the lower temperature you're trying to get to, the higher discharge temp of a refrigerant. And because high discharge temps can be concerning for the sake of the oil and seals and elastomers, et cetera, there are certain mechanisms like direct liquid injection that can help lower the discharge temperature of a refrigerant to preserve, again, that oil and seals. So 22 suffered from high discharge temps. 32 actually has higher than 22 discharge temps. So that might mandate a little bit of a redesign on how a compressor circulates its oil. GWP 677, again, A2L, mildly flammable. 125, you can see all of its attributes here. One of the reasons back, if some of you might remember, when we came out with 410 equipment, it was physically larger than 22. Yes, we also had a SEER change, but this mass flow rate, that means you need 84% more refrigerant flowing through an evaporator to exchange the same amount of heat as 22 did. It's one of the reasons why 410 systems were a little bit bigger. You know, again, 410s, 50% this, 50% that. 143A, really good attributes, but it's mildly flammable and it has a high GWP. 134A, and goes, I'm sorry, 134A, as you can see, is lower pressure, low capacity, and so are these HFOs. So if some of you might be thinking, well, why don't we just go right to the HFOs, considering they have such a great GWP, or low atmospheric lifetimes? Why don't we just go to them, and why go through an interim replacement of 32 and 454? Well, the challenge is, this is why they're lower pressure, lower capacity refrigerants. So you just can't, it would basically be a much larger piece of equipment cooling your house. And we're just not ready for that yet. So that's why we don't have a chemical solution right now to replace in-kind 410A other than 32 and 454. Again, we look at these two gases here, and you can see a lot of blends that are coming out. And folks, I can list, if I were to tell you all the ASHRAE, the new numbers ASHRAE has assigned to refrigerants, I mean, the list would go off the page here. There are so many of them that, and the majority of them have 32, either YF or ZE in there. But they're not commercially, if they don't get commercially available, that means that the manufacturer of equipment is not using it. So there's no sense of me putting all these blends here unless you actually see them being used in applications. And right now, because this transition is happening so quickly, there's not that many being used. There's a couple blends out there, 513A. There's a couple replacements for R134A, basically, that are right now available, like YF in automobiles. And some chillers, like I said, using this product called ZD, or blends of 32 and YF, 513, I believe, is one of them. But for the most part, on high pressure, higher capacity systems, you're not seeing anything just yet other than 32 and 454B soon. But stay tuned, because in the future, we're going to have more blends out there, a mix of an HFO and most likely 32. When we look at comparisons for equipment, air conditioning equipment using 32, 454, 410A versus 32, you do have a gain both in capacity and efficiency. So manufacturers using 32 could probably, in theory, make a smaller piece of equipment to exchange the same amount of heat, if that makes sense. Now, again, we're going to be going through SEER changes. So as you know, when we increase the SEER rating on a system, the two ways to do that, well, traditionally, was to make a bigger coil space, or to improve the efficiency of how the compressor runs, variable speed, etc. But from a heat exchanging capability of the refrigerant itself, 32 can give you that gain alone. Versus 454B, it's basically kind of very similar to 410A. And this might give you an idea of why a manufacturer would choose to go with this product over that product. As I told you, with 32, there might be some enhancements needed to the compressor to circulate that oil better, because it does have a higher discharge temperature. Whereas 454 doesn't have that same issue. You could probably use the same equipment. Obviously, both of these gases are mildly flammable, so therefore they're going to need the safety enhancements in respective systems. So that's going to remain different from 410A, but from the parts and pieces, size, coil thickness, etc., 454B uses really very similar equipment to 410A. So that might be bowed in. And then also it has lower GWP. Right now, there's some folks that think that to get down that step down that we talked about back in like 2030, or forward thinking in 2030, that being at 466 GWP, this gas can be used longer than 32, but there's a lot of debate about that, whether that's actually the case or not, and it's just going to be remains to be seen. The rest of the world, like Japan, by the way, Japan doesn't consider R32 mildly flammable. It's considered A1 or non-flammable. They've been using it for a number of years. And, you know, it probably coincides with Japan's smaller compact systems. You can really package more bang for your buck with a 32 system. Hence, they've been using it for a while. The rest of the world is transitioning away from 410A. This comes from 2018, this data. Here in America, we're not. As you know, 2024 will probably be our big date when we start to see a lot more 32 and 454B equipment. But I just wanted to give you that heads up that the other parts of the world have been using these products. One of the challenges here, because of that flammable rating, flammability rating, all of our codes have to kind of get updated. And that means a lot of committees and assessments, and this stuff is really been going on since 2013, 14. And as you know, that takes time to do all that. And then it has to get adopted into building codes. And then once it gets adopted into the building codes, the states need to adopt it, and then they need to train the individual HJs in each jurisdiction around the state. So it's been a long road. And we're thinking that 2024 is really when you're going to see official building code adoption of A2L refrigerants. They're all being finalized now. What we can expect, well, obviously labeling is going to be big, and the OEMs are going to be picking up their game on giving guidance to the installer on what to do. Looks like right now that a refrigerant sensor is going to be required on a system. Basically, that would probably be in the air handler, and most likely that'd be wired to the motherboard, of course, if it were to trip, and probably initiate a sequence of events, turn off the compressor, leave the fan on, blower on. You know, I can't give you, because the equipment isn't finished yet, I can't give you exactly what's going to happen, but most likely we're looking at a refrigerant sensor and just a lot of training. A lot of this, to tell you the truth, is what really technicians should already be doing. Proper ventilation, purging with nitrogen, all those things they should really already be doing. So I don't necessarily see this as a massive undertaking, but for sure the technicians will have to take a flammable refrigerants test. There's ones out there now. ESCO had one, also been for about a year now. How that gets enforced kind of remains to be seen. I don't know how that is going to happen, but stay tuned for that as we move forward.
Hey, John.
Yes.
Kelly had a question. You might have answered it, but just to confirm, what is going on with the licensure regarding these new refrigerants, and will the public be able to buy it? Also, any special equipment, reclaimers, gauges?
Yeah, well, let me answer the first question. Will the public be able to buy it? So right now, everyone knows that you need an EPA 608 license to buy a refrigerant. And there's actually been some debate on this, because technically you only need an EPA license to buy a CFC or a chlorinated refrigerant. You didn't need it to buy an HFC. And then there was an initiative to change that. And that went through the EPA, but then it got rescinded during the last administration, and then it got reissued. So right now, almost all wholesalers exercise that EPA 608 license to sell any refrigerant, right? And they also utilize that to keep the homeowner out of the store too, to tell you the truth. Moving into the future, now that we're dealing with, and remember, the EPA 608 was needed for environmental purposes. You know, it was, hey, you need to be trained on that so you're not venting that gas to the atmosphere. Whereas now we're doing this for safety reasons. So it's a whole different ball game here. And I can't tell you how it's going to be enforced, whether the OEM is going to require the wholesaler before they sell that piece of equipment to make sure that technician is trained, or whether the wholesaler will be responsible for making sure that flammable refrigerants test has been taken successfully in order to sell the equipment. I don't know, Becky, because it's so new. I can reasonably be assured that wholesalers are not going to be trying to sell, they're going to be scrutinizing who they're selling equipment to, and most likely it's going to be because they're going to want this test on file from a technician. But I just can't say for sure that's the case now, because the equipment isn't out there yet. The equipment that's being sold with R32 right now is small charge equipment. So it doesn't fall under it doesn't have the same safety protocols that are going to be needed for the larger equipment. So, and then obviously when you're dealing with refrigerant sensors, the OEM is not going to want anyone touching their equipment that's not trained on it. But how it's going to get enforced, we have to stay tuned for that. And then as far as equipment, yes, equipment needed is going to require vacuum pumps. And now the word certified for A2L versus rated for A2L2 is going to be different. But as these different OEMs have told me of this equipment, most of it's already certified for A2L, the stuff that they're making right now. But it will be a vacuum pump certified for A2L, recovery machine cert rated for A2L. Like I said, a passing grade on flammables test. I put that in there because I can only assume that's going to be mandated by both OEMs and wholesalers. They just haven't announced that yet. And then that refrigerant detector. Manifolds should not need to be upgraded, other than the software. If you have a digital manifold, obviously you need to get it upgraded for the PT characteristics of the refrigerant. But there's nothing that's going to be needed, like what we call class 1 division 2 or intrinsically safe. That's what we're concerned about when using flammable products in systems. We want the electrical components to be intrinsically safe, and you don't have to worry about that with manifolds. Hopefully, did that answer the question?
I think so. Does
Is there
anybody
any
else have any other questions? You can unmute and give, we can give John a little Q&A.
Yeah, we only have
now.
one more slide left. It's regarding cylinders.
Okay, then let's do the cylinders and then we'll do Q&A.
All right, so cylinders. It's another thing that could change and or might not change. One of the things for sure that's changing is if it's a flammable refrigerant, there's going to be a red stripe around the top of the gas. Like, so R32 cylinder right there, that's most likely what you're going to encounter. ARKEMA and some other manufacturers have announced that they're probably going to go to a gray cylinder with just the ASHRAE designation, and then whether it's a flammable refrigerant will have a red stripe or not. And the reason we did that is we're running out of colors to use, so we thought that just a grayish cylinder with all the nomenclature that's needed and a red stripe to indicate flammable would be the best way to go. So we have chosen to go that direction. But so basically, I think you're going to encounter that in the future. Gray cylinders with just the ASHRAE name on it, and then if it's flammable, it's going to have a red stripe around it. Another change that has been proposed but is being challenged in court is to go to returnable cylinders. And that's the cylinder you see here. This is basically a reclaim cylinder. See the two valves up there? This is being challenged by several different entities. The EPA announced that they wanted the industry to go to returnable cylinders by 2027, and that we couldn't make any more returnables, I think, by 2025, and then they all had to be sold by 2027, the disposable ones. That is being challenged in court. The reason why they want that is because they feel that there's a heel, and we call the heel is a residual amount of refrigerant in the cylinder. They feel that there's a heel in these disposable cylinders. And all those disposable cylinders getting thrown away, that those heels add up. So by going to a returnable cylinder, we don't have that problem. That's being challenged because the industry just, they claim that they were just not ready for it. I mean, the amount of work that's involved for initiating returnable cylinder process here in America is not the same as in like Canada or Europe, where they use a returnable cylinder model. So I can't tell you whether we're going there or not, but you just got to stay tuned. And that court decision, I think, is going to be made this year in 2023. So stay tuned on that. So that cylinder changes. Any questions?
If you guys want to ask a question, you guys can unmute. We have about 20 minutes or the next 10 at least to utilize John's expertise in the subject matter.
I have to apologize. Sometimes I can be confusing. I'd like to do this more live when I can point to a slide. I tried using my arrow here.
Yeah, and those worked. Those worked. Any questions, guys? You'll have to just unmute because we had some background noise, so I muted all but John. I think it was a great presentation, a lot of information. I think you did a great job, but I'm sure there's some questions out there.
Hi, John. This is Brady's. I have a question in regards to this flammable education that we have to give the technicians. Is that going to be federally required, or is that going to be statewide? How is that going to work? Do you know?
I know, and this is what's interesting. It's a good question because the EPA 608 was mandated by the federal government, right? For all technicians. And technically, depending on the jurisdiction you live in. So when I say HJ, I'm talking about authority having jurisdiction. So for instance, I live in Atlantic County, New Jersey. The HJ for Atlantic County is the one who should be making sure that I'm a licensed plumber here to do work on HVAC, right? Some jurisdictions do that better than others. Some it's virtually non-existent. You have people that are not plumbers working on all types of stuff. So we can't depend on the HJ to do it, where technically it is the HJ's kind of responsibility in my opinion. So now this flammable refrigerants test, I would only imagine that the manufacturers of equipment are going to want that a technician to take this test before buying a piece of their equipment. There just hasn't been any announcements on this yet. And I actually at ASHRAE, I thought I could learn about it, and I was surprised that I wasn't getting clear and concise answers. The wholesalers, say Johnstone Supply, or you just pick one, R.E. Michael, Ferguson, they're going to have to mandate it at the counter, I would assume, before they sell a refrigerant. Yes, going to need an EPA 608 to buy the HFC, but you're also going to need a flammable refrigerant test to buy the piece of equipment, I would imagine. But I can't confirm that because it's just, no one knows.
So John, the next question would be, how would we find that out? Is it going to be on ACA, ESCO, maybe ARKEMA's website as things go forward? I'm sure we'll be posting some of this information.
Well, I think that whether the wholesaler is going to choose to do it or not would be the decision of the wholesaler. And so they would be the ones that need to make the announcement. And then whether the OEM of the equipment does, I can only assume they will. You have me thinking now, because we have 32 package, and we have sold some, and now I'm thinking, I'm like, I don't know how that was sold to a technician. Right now, I guess it was sold to the technician because they bought the piece of equipment and that they're trained on that equipment. But I don't know for sure. It's a good question. I'm going to get an answer. I'm going to actually, after I get off this presentation, I'll ask the wholesalers, the respective wholesalers that have sold 32 so far this year, if they did indeed require anything other than a 608.
So Renee
Technically, right now, you only need a 608 to buy a refrigerant.
Okay, Renee Tomlinson said there's been no change for the licensor. So far.
Yeah. Now, again, I'm not trying to take away the safety aspect here, but this is just John Maiorana talking. That's not ARKEMA talk. I mean, these gases are incredible. They're not, like I said, 32 is not even considered flammable in Japan. But everyone still needs to be aware of obviously the flammability rating and all, and that's why we stress that they get trained and they realize, okay, this isn't as bad as a hydrocarbon or with a propane cylinder for your barbecue.
So John, that kind of triggers what you don't have the video in this presentation because it's not really our video, but you show that out on YouTube, if you go and see how flammable it is or the fumes that are released. Can you help direct some of the ladies?
Yeah. So Daikin has a couple videos on YouTube, and there's several other ones out there that show you that these gases are very difficult to light. And when they do light, they don't stay lit for long. And the heat energy they create is not all that great. And the ignition temperatures to light them are higher than your typical hydrocarbon, which is around like 780 Fahrenheit, where most of these are over 1100. And you know, what I tell technicians when I give a presentation is they're working with torches over 5,000 degrees. So at that temperature, everything's flammable. If you even hold it to the side of a non-flammable rag, it's eventually going to light the rag on fire. You know, we use some of those cloths for brazing. So I guess that's, you know, I'm not trying to downplay it, but technicians, you know, with acetylene gas in their truck and oxygen, you know, they already have much more volatile materials than these refrigerants, basically. But I encourage you to go to YouTube and you can see some of the, you know, just how difficult these things are to light.
Not advising you want them to actually light them, just watch the video, right, John?
Yeah, well, yeah, you're going to need, well, I mean, you're going to need like a lot of stuff to kind of light it. You're not going to be able to do it with matches, that's for sure. Okay. Becky, I've mentioned this to you, and I've been told that this isn't a great analogy to use, but it's the only one I can really think of is the word cancer and how some people look at the word cancer. You know, there are some people out there that don't differentiate a 2-centimeter melanoma on your forearm of a golfer, let's say, versus a softball on someone's ovary. You know, one's ovarian cancer, one's melanoma, but yet it's still cancer, and they don't differentiate it. Well, I look at flammability the same way. It's, you know, there's clear differentiations. As the cancer one, I would clearly differentiate. Those are two different, totally different things. Flammability, now that I'm into this, is kind of, hey, listen, this is totally different than hydrocarbons. They're not even comparable. But because it has that word flammable in it, example, Department of Transportation, no differentiation. These gases should be handled, are going to be handled the same way in the eyes of the Department of Transportation as is propane. It's just the way we live. It's just, you know.
Can I follow up to that, John? Since you said that, I've heard that they're going to start transporting. We're going to do the R454B. They're transferring the units dry. Does that make that logical based on the Department of Transportation? Because now I'm paying more for my refrigerant because they're sending, you know, the units dry. I need more.
Well, that's a good question, and I would contradict that, because fortunately, individual charge equipment is not looked at as a combined. So if I have 100 pieces of equipment, all with 100 pounds of refrigerant in it, or let's just say 10 pounds of refrigerant in it, that entire truckload is still only looked at as 1/10 of, from the way I understand it, in it, like, I don't know, I shouldn't say truckload, but in a warehouse, it's not considered 1,000 pounds of gas. It's only considered 10, because the likelihood of all pieces of equipment having a problem where all that gas leaks out at the same time is highly unlikely. So I know for storage purposes, we don't have to consider all the combined gas in the equipment as the hazard, where we do with storage of cylinders. So I have not heard anything about dry shipping equipment, but respective to actual transport, I have to get back to you on that, because you're the first one to bring it up in respect of specifically to transport and not storage. Again, storage, I know we don't have to consider it what am I trying to say? A combined amount of refrigerant. It's only an individual unit. But transport, I have to confirm that.
Thank you.
Does anyone know how many pieces of equipment? Well, I guess it depends on the size of equipment that a truckload holds. They never.
Any other questions? Renee also stated that ESCO does have training program on mildly flammable A2L and GWP. And there's a number of videos on the YouTube channel about it as well. So if you guys want to go to ESCO, they can also help with some of the training.
Yeah, there's a couple. ESCO's not the only one out there, but they're big ones. Obviously, we know with training. But there are a couple flammable refrigerants tests out there.
I know Nate's doing it. ACA has
Nate,
some.
yep.
Artie probably is putting some out there for their wholesalers. So.
Yeah. So if you think of any questions, feel free to just shoot me over an email at arkema.com or forrain.com, contact us, and it'll come to my department. And then we'll get you an answer. If you think of something a couple of weeks from now, hey, let me check to see if that's true or not, like the transportation thing, which I'm going to double check. Feel free to shoot us an email and we'll get you an answer back.